So let's do that for this next one. We have r squared equals 9 cosine 2 theta. So it's r squared, so I know this is going to have 2 petals, which means that they will be 180 away from each other. My max radius is going to be at 3, so square root of 9. I need to figure out where this starts. So it is still cosine, so it's going to be theta equals, 2 theta equals 0, so theta equals 0. So when I go to graph this one, I'm going to go 1, 2, 3. That's where my first one is, 180 way. That's where the next one is. And I draw my 2 petals. And there you go. Next we got r squared equals 36 sine 2 theta. So let's use our shortcuts here. We recognize this as basically a 2-petal rose curve. That's 180 apart for each one of them. Its max radius is going to be 6. Its starting value, okay, so this is different, sine. So sine is going to be normally at pi over 2, so this is going to start at pi over 4. Okay, so I'm going to pretend this is a scale of 2, so this is 1, 2, 3, 4, 5, 6, right there. And then I'm just going to go 180 away from that, and here are the 2 petals that we have. Next we have r equals 5 plus 5 sine theta. So this is different, sine theta. We're now going to not use the 60s, and we're going to use the 30s instead, because sine of 60 is square root of 3 over 2. That's not nice. So we want to make sure that we use the 30s this time. So I'm going to start off by doing a quick graph. It goes up to 5, up to 10, down to 0. Okay, these are equal to each other, so I know that this is going to make a heart-shaped. It's sine, so it starts in the middle, goes down and then back up. So I can fill that in. It's going to go to 5, then 10, back to 5, down to 0, and then back to 5. So that's the pattern that it starts, all right? Middle, top, middle, bottom, middle. I can still do our little 1/2 trick, so I'll do 5 plus 5 times 1/2, so that's going to be 7.5. And that's going to be in quadrants 1 and 2 because sine is positive in 1 and 2, so that's another difference. So I'll have 7.5 in these 2 quadrants. Then I will do 5 minus 5 times 1/2, so that's going to be positive 2.5, and that will be in the 2 quadrants where sine is negative. Okay, so when I start graphing this, it's going to be 0, 5, so that's 1, 2, 3, 4, 5. Then, let's see, it's also 5 at 180, so I'm just going to plot that right now. Let's do 30 and then 7.5, so 6, 7.5, and it's going to be that all the way at 150 as well. Okay, at 90, we're going to be out here at 10. I already got those ones here, so I need this one. 210 is going to be at 2.5. Its counterpart over here will be at 2.5. At 270, we're at 0. Okay, and here we can see we have the upside down cardioid heart shape going on here. Next, r equals 3 plus 6 sine theta. So when I go to graph this, midline's at 3. I'm going up to 9 and down to negative 3. So because I'm going negative, this is going to be an inner loop situation here. Sine, so it's going to go like that. I'm going to cross off all of the 60s because I don't want to deal with any of them with a sine function. And we're going to have 3, then 9, back to 3, down to negative 3, and back to 3. So I'm just following the pattern. Next, let's do 3 plus 6 times 1/2. So that is going to be 6. And that's going to go in quadrants 1 and 2, where sine is positive. Do 3 minus 6 times 1/2. That's going to give me 0. So that's going to be 0 and 0. So let's graph this. 1, 2, 3, right there. That's going to also happen at 180. At 30, we're going to be out at 6, 4, 5, 6, and that's going to happen all the way over here at 150 as well. 90, we're going to be all the way out at 9. And then let's see, 270, we're negative 3, so that's going to actually come inside of the shape, and at these guys we're 0. So I'm going to start by drawing the outer part, and then I will draw the inner loop, which again is formed by that section right there. r equals 5 plus 3 sine theta. Midline's going to be at 5, going up to 8, down to 2. So this is either going to be the dimpled one or the dodgeball. I know it's not the dodgeball because they're not double. So let's graph this super quick. Cross off all of these 60s so I don't get confused. Okay, I'm going to go 5, up to 8, back to 5, down to 2 and back to 5. Then I can do 5 plus 3 times 1/2. So that's going to be 6.5. That will be in the 2 quadrants it's positive in. Then I will do 5 minus 3 times 1/2. That would be 3.5 in the 2 quadrants where sign is negative. And at a certain point, I'm hoping you'll recognize that you actually don't need this table. You can kind of do a lot of this stuff without it once you get a little bit better at thinking about these. 1, 2, 3, 4, 5 here and over there. 6.5, so that's going to be right here and then right there, up at 8. Okay, got that one, got that one. Now I'm going to be at 3.5, 1, 2, 3.5, and then way over here, 3.5, and then at 2. Okay, so because this isn't double, I know it's going to be a dimpled one, so I'm going to purposely start there and make sure that I make that indent there. There you have it. Last but not least, r equals 4 plus 2 sine theta. Okay, so I'm going to have a midline at 4, go up to 6, down to 2. They are double each other, so this one is going to be the dodgeball, which means I'm going to have a flattish surface with a rounded edge there. Don't know why I did that shape right there where I've been writing everything all along, but oh well. Sine goes up and down, not going to use the 60s, so crossing all of those out. Going to go 4, up to 6, back to 4, down to 2, back to 4. Do 4 plus 2 times 1/2, so that's going to be 5 in the 2 quadrants where sine is positive. 4 minus 2 times 1/2, that's going to be 3 in the 2 quadrants where sine is negative. 1, 2, 3, 4. Wrap it all the way around to 4. At 30, we're going to be at 5. At 60, we'll be 1, 2, 3, 4, 5, 6. Did those two already. Here we'll be down at 3. And here we'll be at 2. So this is the dodgeball, so I start by drawing a somewhat flat line between those 3, and then draw the shape right there. And there you have it.